Hello everyone, good morning, good afternoon, good evening, whenever you happen to be watching this. It's Mr. Widmeyer here. First of all, just a quick shout out if you didn't see it on the updates page. Happy belated birthday to Jake K. His birthday was on the 19th, so happy birthday, Jake. Alright, anyway, so today we're going to be continuing with our simplifying. Yesterday we simplified rational exponents, and we're still going to use those properties a little bit today, but we're going to be focusing on simplifying radical expressions. Whoa, radical, like a Ninja Turtle, you know? So anyway, no, but seriously though, the word radical, right, what does that come from? Actually, I'll just briefly talk about that. So the word radical, okay, comes from the Latin word radix, and radix means root. Okay, so when we talk about these things, sometimes you'll hear me say square root or cube root, you know, but that just is the same. It's synonymous with the word radical. You can, okay, this is also like a, a radical symbol too, is what that symbol is called. This is also a radical symbol too. Okay, that word radix, right, you might recognize from the vegetable radish. Which, where does it come from? It comes from the ground, like a root, you know, kind of thing. So anyway, just a little tidbit there about why we call these radical and roots kind of interchangeably. All right, so what we're asked to do here is to simplify the expression by rewriting using rational exponents and using their properties. All answers should have positive exponents. Okay, so looking at this, we'll just use what we talked about yesterday, right? So we have a square root there. Remember that a square root is the same thing as raising it to what exponent? It should be the 1/2 power there, okay? And then right here, we have a cube root, and so what exponent is the same as a cube root? Well, that'll be 1/3, okay? And then we have a power raised to a power. Do you remember from yesterday? What do? We have a power raised to a power. How do we simplify that? We multiply. So 3 times 1/2 is 3/2. And the same thing here. 2 times 1/3 gives us x to the 2/3. Now we're not quite done yet, because we can also simplify these these exponents one more time. Again, we have a common base. They both have a base of x here. Okay, so to simplify that, we will just do what with our exponents? And it's subtract. Okay, so we'll do 3/2 minus 2/3. Okay, if you have a graphing calculator, you can type into your calculator, parentheses 3 divided by 2, parentheses minus, parentheses 2 divided by 3, parentheses, and then hit enter. You'll get a decimal, and then hit math, enter, and you'll get converted to a fraction. Okay, for our purposes, I'll go ahead and just do this little side calculation over here. I'll show you how to do it by hand. So 3/2 minus 2/3. We can't we can't subtract those because we don't have common denominators, but our common denominator, if we multiply this by 3/3 and this by 2/2, we'll end up with 9/6 minus 4/6, which gives us 5/6. And so our final answer here is x to the 5/6 power. And there's our answer. Okay, so let's keep going here. The next problem, again, we have a cube root here and a cube root here, so that's like raising to the what power? Okay, it should be the 1/3 power, right? And so x times 2y to the 1/3 times 4x squared y squared, also to the 1/3 power. Okay, now, one thing you could also do here, since these things are both underneath the cube root, you could actually multiply this stuff here together first, and then raise it all to the 1/3 power. That's an option, but we're going to do it keep it separate just because that's where I've started here. Okay, so now this power will distribute, so it becomes 2 to the 1/3, y to the 1/3, times 4 to the 1/3, times x to the, well, 2 times 1/3 will be 2/3, and then y to the 2/3 as well. Okay, so this is all one big product here. Let's see here. So the x can multiply with this x, and again, this is x to the 1 here. So since we're multiplying, what do we do with our exponents? Whoops. This 1 and this 2/3, we are going to add them because it's, when you multiply, you add your exponents. So we get x to the, now 1, remember, is the same thing as 3/3. Okay, so we're going to take 2/3 and add that to 3/3, so you get 5/3. And then the 2, well, that goes with the 4 there. Okay, now they're both have a power of 1/3. So we could multiply them and get 8 to the 1/3 power. Okay, again, you can also type in your calculator just 2 to the 1/3 power times 4 to the 1/3 power, and you're going to end up with 2. Okay, and the reason for that is because this is really just equal to 8 to the 1/3 power. And the cube root of 8 is just 2 there. So we get 2. So I'll put that 2 out front here. Okay, so again, we took care of the x's, took care of the numbers, and then y to the 1/3 times y to the 2/3 will give us y to the 3/3. What's the same thing as 3/3? Well, that just simplifies to 1. So we'll just give it a 1 like that. And there's our answer. Okay. All right, next one. All right, this is, so we have different roots here. So this will become 16 to the 3rd to the 1/6 power. This here is 4 to the 6th to the 1/4 power, again because it's a 4th root there. And then this becomes 8 to the 2 to the 1/3 power, like so. And again, we have a power to a power, power to a power, power to a power, okay, power raised to a power. So we will multiply them. So it becomes 16 to the 3/6 times 4 to the 6/4 times 8 to the 2/3. Okay, now this will simplify to 16 to the 1/2 times 4 to the 3/2 times 8 to the 2/3. And again, you can type all these in your calculator if you want to. 16 to the 1/2 is a square root of 16, remember, which is just going to give us 4. Okay, 4 to the 3/2, well, that's like saying the square root of 4 to the 3rd. Now, we already know what the square root of 4 is. It's 2 to the 3rd, so 2 to the 3rd is just going to give us an 8. And then 8 to the 2/3, well, that's like saying cube root of 8 squared. Now we already know the cube root of 8 is 2, so it's 2 squared, so we just get 4. And so it's 4 times 8 times 4, which is, let's see here, 32. So 4 times 8 is 32, times 4 is 128. Okay, and again, you can type this whole mess in your calculator. Remember, to do roots that are not square roots, you have to press the math button and then arrow down to option 5, okay? When you use that option 5 there, you want to make sure you type whatever root you want first. So if you want the 6th root, you would type a 6, then press math, arrow down to number 5, okay? There's x root, and then that'll make sure you get the 6th root, and so on and so forth. Okay, but there's our answer. All right, now talking about some properties of radicals really quick. So, we already mentioned, I think, this somewhat when I was talking about simplifying square roots with you guys back when we did quadratics and things. So just as an example here, let's say we want to take the cube root of 16. Well, if you type cube root of 16 in your calculator, you're going to get this nasty decimal. But that doesn't mean it can't be simplified nicely. So, for example, if you break 16 into 8 times 2, and now why 8 times 2? Because 8 is a perfect cube. Okay, and so and the 2 is kind of what's left over there. Okay, so that then allows us, when you have a product there inside a cube root, you can break it up into 2 cube roots. Okay, see, there's 2 separate ones, and again, we're multiplying them together. And that allows us then to take the cube root of just this 8, which becomes this 2 right here, and then this cube root of 2, we can't really simplify it anymore. We can't pull any more perfect cubes out except for a 1, which wouldn't reduce it. And so our final answer is this right here. Okay. And then likewise here, if we want to take the square root of 25/16, okay, so that's 25 divided by 16. And so when you divide in a square root, you can break it up, make it root 25 over root 16, and break it up into 2 square roots. And then we know what the square root of 25 is. It's just 5, and the square root of 16 is just 4. And so that's our simplified answer. So let's take a look here at some problems. I think I've got just 2 for us, yes. Okay, so in this case, what I would really encourage you guys to do, so some options you have. Option 1 is just to see, can you cube root 256 in your calculator without having to, like do any simplifications. Let's see here, 256 to the 1/3 power. 256 is not a perfect cube, so we need to rewrite it as some power. Okay, and so this is where you kind of have to guess and check a little bit. Can we rewrite 256 as like a power of 3? So like, is 256 equal to 3 to something? And you would get this, you would just want to like guess and check essentially by like doing 3 times 3. Well, that's 9. Let's try another 3. That's 27 times another 3. That would be 81. Whoops, I'm getting ahead of myself here. times another 3 will give us 243 times another 3. Well, that's going to be too big to make it 256. So in other words, 256 is not a power of 3. We can't just get it by multiplying a bunch of 3's together. Let's see here. It is even. Let's try multiplying by 2. And in fact, 256 is a power of 2. Okay, 256 is 2 to the 8th, I want to say. Yes. Okay, and then x cubed will stay x cubed, and y to the 7th will stay y to the 7th. And instead of a cube root, let's go ahead and rewrite this, because I think this will help us with simplification. Let's rewrite this cube root as to the 1/3 power. Okay. Now you also might have looked at 256 and said, oh, Mr. Widmar, that's also 4 to the 4th. Maybe you came up with that way. And that's also true. So you could use that to help you too if you wanted to. Okay, but I'm going to use the 2 to the 8th there. Okay, so now we have a power to a power, so we'll distribute all these powers here. So you get 2 to the 8/3, x to the 3/3, y to the 7/3. And then what we want to do here is, you see how we have these improper fractions here, where the numerator is bigger than the denominator? We're going to break up these fractions. So I'm going to make it 2 to the 3/3 times 2 to the 3/3 times 2 to the 2/3, right? The 3, and the 2 combine together to make this original 8, but by breaking it up, I now create these nice whole, 1 unit, parts that'll simplify nicely, and then this leftover part that won't simplify anymore. Okay, and so that makes this 2 to the 1 times 2 to the 1 times 2 to the 2/3, like that, which is just really just 2 times 2 times 2 to the 2/3. This x simplifies nicely already. It's just x to the 1. And then this y to the 7/3, well, again, I can break that up just like I did with the 8/3 there. So I can make a y to the 3/3, another y to the 3/3, so that's now 6, and then I have a y to the 1/3 left over. Okay? Oops, actually, I should have done that right here. So I'm just breaking up this fraction into these pieces here that create, whole units, that simplify very nicely, and then this leftover piece that I can't really simplify nicely. It's kind of like dividing it up, Okay, so now what do I do? Well, I'm going to recollect all of these terms here that have, just an exponent of 1. So I'll get a 4, because that 2 times 2 makes 4, an x, and then a y and a y will make y squared. And then what's left over? Well, both of these right here have a 3 in their exponent's denominator. So that means I can then just make another cube root, and then it'll be 2 squared, which is, if you want to just make that 4, that's fine. Oh boy, I did something funky here. There we go. And then the y is just y to the 1, so 4y to the 1, like that. And there's our final answer. Okay, a little complicated stuff, but there it is. Let's see a little more simple answer, and then I'll stop here. 4th root of 81 over x. So again, 4th root, we want to go ahead and just check to see, can we take the 4th root of 81 like so? And yes, we can. The 4th root of 81 is, well, 81 is 3 to the 4th. And so we get 3 to the 4 over 4 equals x to the 1 over 4, which gives us just 3 over x to the 1/4. And I'm okay with you stopping right there if you want to. The book does want you to rationalize the denominator. I'm not going to have you guys worry about rationalizing the denominator. I think it's just more work than we need to worry about right now. Okay, so take a look at, after taking a look at this video, if you still have more questions, or take a look at the homework at least, see what you can get done, and then ask me any questions that you guys might have about simplifying and stuff like that, because this can be pretty tricky. So anyway, thanks guys, and we'll catch you later.